we're doing addition, subtraction, multiplication today, and then we'll do division. There's two different kinds of division that we'll do on Friday, so that's why I kind of separate those, and we'll talk about those things and how that's going to relate to taking polynomials. And today we're going to put them together. Well, next week our job is going to be to take them apart and more or less factor them completely. So it's like doing all the things that we did with quadratics. That doesn't go away. You still got to know that. If you didn't know it when we were doing quadratics, you need to learn it. And so you need to make sure that you nail that down as we go here. So the main instruction along the way is just simplify. And when we simplify anything in algebra, what does that mean? Make it smaller and reduce it as much as we can. Put what together? Like terms. Okay, so the whole idea is simplifying by making it smaller, putting like terms together. When we're adding and subtracting, like terms is the whole thing. We've been doing that for years. Let's say we had a polynomial x squared plus 3x minus 5, and we're adding another polynomial, 3x squared minus x plus 7. Two quadratics there, but if we're adding, all we're doing is putting like terms together, and we want our answer to be in descending order, just like it was when we were trying to factor a polynomial. So like terms, start with the first one. What's like x squared? So when you add them together, x squared plus 3x squared is 4x squared. Easy stuff there. So 3x plus negative x would be plus 2x. Negative 5 plus positive 7 plus 2. And you have added some polynomials. Been doing that for years. It's nothing new. The only thing that's going to be changing with Algebra 2 is they're going to put a bigger exponent on it. That's the only thing that's really changing. They might do this to you. 3y to the third minus 2y squared minus 7y. A bit of a delay today, isn't it? Plus negative 4y squared minus 5 plus 2y. Okay, so they're trying to kind of confuse you a little bit here, make it bigger, and then not have it in the right order to start with. So still, when we're trying to simplify by addition or subtraction, we want to put the like terms together and then start with your highest exponent. So what's the highest exponent here? Y to the third. So is there any like terms that go with that 3y to the third? No. So nothing to add to it. So we're just going to bring it down. And then next, y to the second. So we got negative 2y squared plus a negative 4y squared. Be a minus 6y squared. Good job. And then we got plain y's. So we got negative 7y plus positive 2y minus 5y. And that's almost everything. There's a minus 5 that's in the second polynomial that we've got to take care of. So it's still there. And eventually, maybe we'll show up on that screen. Can y'all see that? There it is. So minus 5 there. And it's in the right order. And that's the way you don't have to work it in that order, but you have to report your answer in that order. Okay, so if you wanted to work it in a different order and put the like terms together, that's fine, just as long as you write your answer in that order. That's what we want there. I just work it in that order. If I'm going to have to write my answer in that order, I work it in that order. It's just one less step I got to do. Okay, so you make your choice on that as far as that goes. Mathematically, doesn't matter, just as long as you report your answer that way. Let's do a subtraction problem. Subtraction is the same rules. You're putting like terms together and just putting in descending order at the end. The kicker that always causes people to miss things with the subtraction is that they forget to subtract each term. They will subtract the first term and then forget to use that minus sign again for every term after that. So start with something simple like 5y squared plus 6y plus 7 minus 3y squared plus 8y minus 6. And most people will get that first term correct. They'll go 5y squared minus 3y squared is 2y squared, and they get that right. But then they mess up and they'll say, okay, 6y plus 8y is 14y, and they'll write 14y down. But that's incorrect because it's 6y minus positive 8y. So you're using that minus sign every time. So what is 6 minus positive 8? Negative 2y. You got to be careful of that. And then the next piece, you got 7 minus negative 6, so a double negative there. So that ends up being 7 plus 6, which is plus 13. So sign mistakes tend to be still, for every math class that's ever been, that's the most common mistake once you got into the stuff when you're using positive and negative numbers, sign mistakes. Be careful of that, especially on the subtraction problems, because it's so easy to mess up on that. So let's do one that's a little tougher. 6y minus 8y squared plus 11 minus parentheses negative 6y cubed plus 4y squared minus 8 plus 10y. Yowza. Long problem, or it looks like a long problem, but not a greatly strenuous problem as far as what kind of math we got to do. So we're subtracting polynomials, so we're going to put like terms together. And again, we want to start with the highest exponent on our variable. So what's the highest exponent? Y to the third. So we got a negative 6y cubed. So what is that when I work it out? Does it stay negative 6y cubed, or does it become? Yeah, that double negative right here. So there's no like term in the first polynomial, but we're subtracting nothing minus negative 6. So that's where that's going to change into a positive 6y cubed. And so one thing that might help you if you easily get distracted or your eyes kind of jump around sometimes, once you use a piece, if you want to mark it out, that can help you just know, hey, I'm not using that anymore. I'm done with that. So that might be a useful tool for some of you. I know sometimes if it gets too jumbled, it's hard to figure out what's going on. What's next? Y squared. So we got a negative 8y squared in the first polynomial minus positive 4y squared, which would be negative 12y squared. So we're done with those. Next, plain wise, 6y minus 10y would be negative 4y. Easy stuff here. And then plus 3. Which one is it? 11 minus a negative 8. That's a double negative, so that would be the plus 19. Sign mistakes. You got to watch them. They'll get the best of it. Okay, so there we have a polynomial at the end. So next week we'll be taking this and breaking it down and finding out some other things with that. So, but goal today is putting together some polynomials using addition, subtraction, what we've done so far, and then we're going to do multiplication next. So stuff you've done before, just reviewing that thing before we get into the actual Algebra 2 part of it. So still simplifying, even though the problem looks slightly different. What operation is going on with these? Multiplication. And in multiplication, how do we multiply x plus 4 times 3x plus 5? It's distributed property twice. So I'm distributing x to both of those pieces. So that'd be 3x times x would be 3x squared. X times 5 would be plus 5x. And then I'm multiplying positive 4 to both of those pieces. I'm using the plus as the sign. So whatever sign is right there, make sure you take it with you when you multiply. So it's a plus 4, so I'm using positive 4. So 4 times 3x would be 12x. And then 4 times positive 5 plus 20. So, and then simplify from there. Again, we're going to try to make it as small as we can. So 3x squared plus 17x plus 20. we've done that a long time. We've been doing that. Did that in Algebra 1 a lot. Probably did that in 8th grade math, I'm sure. But nothing just incredibly difficult. Let's look at more of an Algebra 2 level problem that's similar to that. X squared plus 4 times 3x cubed plus 5. So they just make it bigger as far as higher exponents. We're dealing with the whole unit we're in right now is starting today is called higher degree polynomials. So the exponents are just going to be bigger on this. So higher degree means just higher exponents. So again, it's multiplication. Is this any different than the previous example? It's exactly the same thing. It's just going to have different answers. So when we distribute x squared to both of those pieces, that's going to give us 3x to the 5th. Remember, when you multiply, you add exponents. So x squared and x cubed, 3 plus 2 is 5. So that's where that exponent of a 5 comes from. And then x squared times a positive 5, that's just 5x squared. And then we multiply by the 4. So that'd be plus 12x cubed and plus 20. Now, we multiplied it, distributed property. Is it in the right order to say that's my answer? No, we're going to need to fix it. So 3x to the 5th plus 12x cubed plus 5x squared plus 20. That's what we want to end up with there. Descending order at the end. Getting that habit now, it won't be an issue at all later. Okay, easy stuff there. All right. Well, let's do another one. 4x to the 3rd minus 5y squared. Hey, that looks short, right? So it's 16x to the 6th minus 25y squared, right? No. What's it mean to square something? Multiply times itself. So this is really the same problem as this. We got two variables in this one, but again, it's not a super difficult thing here. But to square something means multiply times itself. So 4x cubed minus 5y times 4x cubed minus 5y. And then we just do the same thing we've been doing. Multiply it out. 4x cubed times 4x cubed. Well, there's that 16x to the 6th that I said earlier. But here's where we would have missed it. 4x cubed times a negative 5y. 20x cubed y. I'm just putting that in alphabetical order with the letters. Technically, you could put y x cubed if you wanted to, but my brain says you got to put it in alphabetical order. Most mathematicians would put it in alphabetical order anyway, because that's standard practice. And then you distribute the negative 5y to both of those. So there's another negative 20x cubed y. And then what's negative 5y times negative 5y? Positive 25y squared. Now, these are a little difficult to decide what order to go in. Usually, if I'm going to do descending order with something that's got two variables, go with the first variable. So whatever one is the closest to the front of the alphabet. X is closer, so I'm going to go descending order by X. And the Y, it'll just be what it is. Okay, so like terms, we got some. Yeah, those two in the middle there, both are x cubed y's. They have the same variables, same exponents on those variables. So we can put those together, and that's going to be 16x to the 6th minus 40x cubed y plus 25y squared. And again, if you got more than one variable, descending order wise, just go by the one that's in the front, the closest to the front of the alphabet. So that's the one you want to descend by. You won't have a ton that have more than one variable, just trying to mix it in here. So there's a, more of an Algebra 2 level problem. Let's look at, I think I did this one with my Algebra 1 kids this year. We've already done this with them. So. But it's still worthy of reviewing to make sure you guys remember how to do that. That's what I expect you to be able to do. So, what are we multiplying by here? Yeah, just distributes across there. That's a monomial, because it's only got one term, times a polynomial that got 4 terms. So it's just distributive property. So we're taking this big polynomial, making it bigger by multiplication. So we're just distributing. And I draw those lines for absolutely no reason. So negative 6x to the what? 7th. Negative 3 times negative 5 would be plus 50. X to the 6th, 4 plus 2. That's where the 6 is coming from. And then the next piece, x to the 5th, 4 plus 1. Because that x there has a 1 exponent that's never written there, but it's there. Okay, and then the last piece, and it's in descending order because it started in descending order, so it should stay that way once you do your distributive property. Okay, not too hard. Pretty easy stuff there. Let's do something a little bit more intense. Let's take a binomial. Blake?
So, all of those are like terms, right?
No, none of those are like terms. Because they have a different exponent on the x. They all have an x, but there's a different exponent on each x. So that makes them not like terms. They have to have the same letter, the same exponent on that letter to be a like term. All right. Let's take a binomial, 2x squared minus 5, and multiply it times a larger polynomial. Let's do 1 plus 3x squared minus 5x plus 2x cubed. That is definitely not in descending order to start with. But it doesn't matter what order it's in to start with. It only matters what order you finish. Right? It's kind of like a race. It doesn't matter who gets off the line first, who crosses the finish line first, right? So you can rearrange it at the beginning if you want to. I don't, because I don't like to rearrange it at the end. So it's either rearrange at the beginning or rearrange at the end. I'm a rearrange at the end person. When I'm combining like terms, if there are any, I'll rearrange it. Okay, so what's going on here? What do we do? Distribute. How many times are we going to have to distribute? Well, a bunch, but it's once for 2x squared. So 2x squared is going to multiply times everything that's in there, right? And then we're going to multiply, after we do that, negative 5 times everything that's in there. Okay, so there's, somebody said 8 multiplications that are going to happen, and then there's some additions that are going to happen as well. Now, I'm going to show you how I like to do these. It's a strategy as far as that goes. It's not necessarily the only way to do this, but I think it'll help you. When I distribute here, I'm going to distribute 2x squared times 1, and I'm going to write those on this first line. So that'd be 2x squared, and then 2x squared times 3x squared would be plus 6x to the 4th, and then minus 10x cubed plus 4x to the 5th. Okay, so that's just distributing the 2x squared. Next, I'm going to distribute the minus 5, but I'm going to write those on the next line and try to line them up with the piece that they're like. So I'm going to kind of put my like terms together as I go. So negative 5 times 1 is going to give me a minus 5. Is there anybody here that would be a like term to a minus 5? No, so I'm just going to write that on the end down here. Then I multiply negative 5 times positive 3x squared. Negative 15x squared. Well, there's an x squared right there, so I'm going to put that underneath that. And then I'm going to say -5 times -5x would be positive 25x. Is there anybody that's got a plain x? No, so I'm just going to put that down here on the end. -5 times positive 2x cubed. -10x cubed. There's some x cubes right there, so I'm going to put that under there. What that allows me to do then is have my like terms stacked up. So I know, hey, I just got to put these two together and these two together. These guys don't have like terms, so they're just going to be added into the problem in the right spot. So that's a strategy that I use, keeps me from having to write a problem that's this long on a paper that's this wide. And so that might be something useful to help you along the way. What's our first term in the answer? What should be in the front? 4x to the 5th, because it's got the highest exponent. Now what? Plus 6x to the 4th. We've used that one. We've used that one. Now what? Minus 20x to the 3rd. Good job. Use both of those. Minus 13x to the 2nd. Plus 25x. Minus 5. And we've taken that whole big thing and put it in the right order and got all our like terms together. A little bit of a long problem, a lot of operations, like 8 multiplications, and then 1, 2, so 10 operations, and we can count this as a 11th thing where we put it in the right order out of that. So quite a few things going on with that particular problem. Let's look at this problem, which looks easier. Maybe isn't as quite as easy as it looks. What's it mean to cube something? Yeah, write 3 of them down, multiply them all together. So we're going to write down x plus 3 times x plus 3 times another x plus 3. So we're multiplying out, we're cubing a binomial is what that is. And you don't want to distribute across 2 of them at the same time, because that gets way too complicated. So I would just pick 2 of them to work with. Focus on those 2 first. Get that answer, and then multiply by the other one. That's the best strategy to use here, or a strategy to use. I don't know if it's necessarily the best, but it's one I use. I tend to think that I'm the only person that could do it right. So multiplying x plus 3 times x plus 3. The 2 that are in the brackets there are ones I'm doing first. It doesn't matter which 2 you do first. If you wanted to do these 2 together first, that's fine too. I like doing it that way because it's the normal way we're used to seeing it. So x times x squared, 3x, 9. And then I'm going to simplify that piece to get x squared plus 6x plus 9. And then I have to multiply that by this other x plus 3. And then it's just another distributive property to do. Okay. X times x squared is x cubed plus 6x squared plus 9x. And then multiply everybody by the 3. So that'd be plus 3x squared plus 18x plus 27. And because it was already in order, that's where the stacking it up really shines and looks nice. Is now your like terms, there's 2 sets of them, they're stacked up together like that. Doesn't look quite as jumbled and crazy looking. So x cubed plus 9x squared plus 27x plus 27. multiplied that out and got the answer. Not too bad. Let's get one that's maybe a little more. That's definitely Algebra 2 stuff. We didn't do a whole lot of cubed things in Algebra 1. We did a lot of squared things. Example J. Or did I skip a letter? I did I twice, didn't I? Math guy, not an English guy. This is example K. All right. Let's take a trinomial, 3x squared minus 5x plus 8 times a trinomial, negative 7x squared plus 2x minus 9. And they're already in descending order. Both of them are. So the stacking method is really going to do good on this, because this is a pretty long problem because it's trinomial times trinomial. So that's going to be 9 different multiplications that we've got to do. And then we got to do some additions or subtractions to combine the like terms out of that. So that's it's a lot of operations there. The kicker with this stuff is it's a lot of operations, so there's a lot of places that you can just make a simple mistake. It's not necessarily you don't understand what you're doing, but it's just hey, I misadded or made a sign mistake along the way. So there's a lot of pieces to this, and you got to pay attention to details. So multiply across there. I'm going to start with the 3x squared. So what's my 3x squared times all that other one? That would be negative 21x to the 4th plus 6x cubed minus 27x squared. So that gets 3x used up. And then I would multiply everybody by negative 5x. That'd be negative 5 times negative 7 to be positive 35x cubed. Negative 10x squared, positive 45x. So that uses up the 5x. And then distribute the 8 to the rest of that. So positive 8 times negative 7 be negative 56x squared, positive 16x, negative 72 for the constant. And then we just need to put all that together at the end. So negative 21x to the 4th doesn't have any like terms. Add my x cubes together, 36 and 5, or 35 and 6, excuse me, same number. 41x cubed, right? Negative 27, negative 10, negative 56, all of those are going to come together to be a negative 93 x squared, 45 and 16, 61 x, and then the minus 72, nothing else is like it. So and there we have big long polynomial that's in descending order. All right. So it's pretty easy when there's one variable. When there's two variables, it gets a little tougher, but the operation part is still the same. So like if we had 4x squared y to the 3rd plus 2xy, and we multiply that times negative 3x to the 4th y minus 5x squared y. So binomial times a binomial, so it's not incredibly long, but it's got a lot of variables in it and several exponents, so we've got to kind of be mindful of that. So still got to be distributive property though. 4x squared y to the third. And one thing that some people tend to get confused about is the fact that you can multiply any two things together. It's adding and subtracting that the rules apply to. Okay, so just because it's x squared y cubed doesn't mean you can't multiply it times the other stuff. You can multiply anything together, but adding and subtracting, you've got to have the same variable, same exponent on that variable. So 4x squared y cubed times negative 3 x to the fourth y would be what? Good job. Then the next piece. Fourth. Good. And then next piece. Y to the second. And then last piece. Again, descending order is a little muddy on this because it's got two variables, but we want to go by the variable that's closest to the front of the alphabetical order, so we go by x. So I just need to swap the places of these two pieces in the middle so that the x to the fifth is second. So that'd be negative 12x to the sixth, y to the fourth, minus 6x to the fifth, y squared, minus 20 x to the fourth, y to the fourth, minus 10 x to the third, y squared. And now it's in what we consider descending order. Again, you're going to go by that letter that's closest to the front of the alphabet, the alphabetical order. So multiplying more than one variable, bigger exponents, that's the algebra 2 part of this stuff. The operation wise is the same thing you did in algebra 1. It's nothing new. Let's do one more example and we'll be done. X plus 7, parentheses, and then the multiply that times 3x squared plus 2x minus 4, and then subtract x minus 4 times x squared minus 8x plus 1. This is the combination of everything. It's got multiplication, it's got an addition and subtraction in there. So it's just a combination of everything that we've talked about today. And we've got to follow what rules as far as this problem goes. What are the rules you have to follow? Multiplication first, then addition, subtraction. So we're going to multiply out the first two together and the second two. We're going to multiply those two out together as well. Then we'll do the subtraction last. So we've got to be careful of that as we go. So we got to remember we're subtracting the second polynomial that we get. So first one, not too big. You know, you got x times 3x squared, that's 3x cubed, 2x squared, negative 4x, and then I'm multiplying 7 times all of those. So that'd be plus 21x squared plus 14x minus 28. And then I'm going to combine my like terms. So 3x cubed plus 23x squared plus 10x minus 28. And that's the answer to the first multiplication problem. That's kind of how I would do those. We'll crank that out, and I'm going to subtract away the answer to the second multiplication problem. Let's do that second multiplication problem. Don't worry about the minus sign that's in front until we get down to here. So we're just distributing x minus 4 to that polynomial. So that's going to be x cubed minus 8x squared plus x. Get you all those. And then the other negative 4x squared positive 32x negative 4. combine those like terms. Now we can do the subtraction that is there. Order of operations, Blake told us you can do that multiplication first, and then you can do the other stuff. Or exponents have to be, parentheses, exponents, multiplication, division, addition, subtraction, all those left or right as we go. So like terms, we got 3x cubed minus x cubed would be 2x cubed. Those two are gone. What about the x squareds? Positive 23 minus a negative 12. Positive 35. Good job. Okay. Plain x's. Minus 23x. Good job. 10 minus positive 33. You did pretty good. Don't last that long because I didn't think it would. All right, sorry, I'm finish it. Last one. Oh, come on. There you go. Negative 28 minus negative 4. Minus 24. So 3, 6, 9, 12, 13, 14, 15, 16, 17, 18, 19, 20 operations to do that problem. And if you miss one of them, you got the whole thing wrong. A lot of operations in this stuff, so it takes paying attention to detail and making sure that you're putting like terms together. Sign mistakes are going to be the biggest issue, so be careful of those things. Okay, I've assigned some things on Khan Academy. You can go ahead and start working on those. You got plenty of time to get going with that today. Some of them are going to be quick and easy. It's real simple things. Some are going to take a little bit longer, like this kind of problem on there. So you want to go and get started with that. We'll have a work day tomorrow, and then Friday we'll move on to the next thing. Okay, so work day is starting today and working tomorrow. These are the first things that were assigned for this 9 weeks. So make sure you don't get behind. Get ahead as much as possible.